Alright, let's get into VLANs a bit. So we was talking about some trunks and such before, and that dynamic issue that came up. So let's get into the basics of VLANs. So VLANs are virtual LANs. So what does that mean? That means it's a way to segment up your network so that you can have multiple networks on the same equipment. So think of it as, if you think of it as in a vertical format, you have some sort of like a switch with some PCs coming off of it, and then this might be network number 1, and then another switch, and then some PCs coming off, and then this might be network number 2, and so on. And then that's number 3. Now consider these 3 switches all as one. So take this idea and we're going to condense it down into one device. So now in reality we have one switch that has networks 1, 2, and 3 on it. That's what a VLAN is essentially. So we have all these different separate networks, but it's on one device. So if you're in a very basic environment, you might have one network right now. You might have one VLAN essentially, which is very common in smaller environments. So right now if you plug into a switch, and it doesn't really matter what port you plug into, and just you get a connection, everything works, and everyone's on, you know, good old 192.168.1.0/24, well then you're on a flat network. So a flat network is only one subnet, only one network essentially. When you get into slightly larger businesses and more complex environments, you're going to be using VLANs a lot. They're very common. So what you end up having to do is define what ports on your switch are for which of these different VLANs, which of these different networks. So if we blow up that switch and we get a little bit closer to it, we're going to have some ports on there. No longer can you just plug into just any old port and get a connection. You're going to have to go in and manage the switch. So this is where that whole managed switch and managed infrastructure comes in. If you don't have a managed switch, you can't do this. So if you have fixed configuration switches that are unmanaged, you need to upgrade essentially to be able to properly use VLANs. So it's worth it for the extra bucks to go with a managed switch so you can do this. Now VLANs are based off of layer 2. So it doesn't matter what IP scheme for layer 3 are on any of these networks. VLANs are a layer 2 technology. So it's, as I drew there, basically it's similar idea to having a separate piece of hardware for each network. But instead of a separate piece of hardware to separate out the networks, we're just going to assign different ports to those different networks. So this might be, you know, VLAN 1. This one's going to be assigned to VLAN 2. And then this one might be assigned to VLAN 3. And then the device that's plugged in there is going to have to be configured appropriately for that VLAN. So this one and this one and this one, they might have different IPs. Well, they have to have different IP schemes. So this could be the old 192.168.1.0 network. This one might be 10.0.0.0/ I don't know, 28 or something, who knows. And then this could be, you know, 172.16.1.0/24, whatever. So you can have different networks, completely different IP schemes, completely different layer 2 divisions between these, and it'll all work on one device. So it's very powerful. The only thing that you have to do is then configure which ports are for what VLANs. So it's common that you'll do these in ranges, where ports 1 through 8 are this VLAN, and then ports 9 through 16 or these VLANs or something like that. You know, you'll have some sort of system you use. But the way of virtualizing your network infrastructure in a way that so you don't have to have as many individual pieces of hardware and individual switches. And this is where that power comes in when I was talking about dividing up your network in a way that it makes sense. So you have, maybe this could be the HR group, remember? This could be the old network, it could be like the legacy network for IT. This could be the printer network, something like that. And that way you can segment out the broadcast traffic. Remember I was talking about limiting the amount of broadcast traffic? This is how you start to do that. You make VLANs, make your new IP scheme for that VLAN, and now the broadcast traffic has reduced because you're separating people into different networks. You can also do access control lists. So between these different layers, between these different networks, these different VLANs, you can then apply access control lists, and you can say, you know, this green VLAN can't access the blue VLAN, and the purple VLAN can only access the green VLAN, and vice versa, and only on certain ports and only to certain destinations. And you can get really fancy with it if you want. That's some of the power that you have to do this. So we have a couple different types of VLANs. There's data, voice, management, defaults. Let me blank this out and we'll write these down. So we have data VLAN. So this is, we'll start out with default. We have default VLAN. Remember I mentioned that in the other videos. We have a VLAN 1, and everything is assigned to that. So the default VLAN is VLAN 1. If you assign a management IP address to a device, it's going to be the VLAN 1 unless you make it something different. So this is also the one that we consider to remain enabled on the device, but move everything else off of it. So it's to a different VLAN, so it's a little bit more secure, and you want to move your management access off of this too. But the default is 1. The other type we have is, well, we'll do the data VLAN. That's used for, you know, PC traffic, computers, end nodes, fire control panels, as I've mentioned, whatever it is, something like that that needs to access the web or needs to send SQL data back and forth or something like that, servers, you know, they'll be using the data VLAN. It's probably the most common one. It's going to be some sort of data VLAN, and you can number them whatever you want, basically, and we'll go through that. So we also have voice VLANs. Those are kind of special. They're used for VoIP phones. Remember that one example I was trying to attach the VoIP phone, but I didn't have power over Ethernet set up on the switch? So that's where the voice VLAN will come into play. And in those kinds of connections where you have a switch and then you have some sort of phone, the VoIP phone, and then you have a PC sitting over here, going from the switch, and we'll get into this, but going in from the switch to the phone, this is going to carry 2 VLANs because we need a data VLAN for the computer, we need a voice VLAN for the phone. So there's going to have, you know, VLAN 5 and 10 is going to be on this connection. And then one of those VLANs is going to stay here, so like this might be VLAN 5. VLAN 10 will get passed on to the computer then. And then that will be used as the data. So this would be our data, and then this would be our voice. There's usually some sort of quality of service on that as well. So we'll talk about that. But this connection here actually is used with a special command. It's different from a trunk. And what this really is a trunk. A trunk is a connection that allows multiple VLANs over that cable. Because otherwise, if we didn't do that, you would have to have a separate cable for VLAN 5 and for VLAN 10 in this example. So that's a waste of ports. If we have 20 VLANs, you'd have to use 20 cables to make that work. So what we do instead is we use one cable and we just say, hey, you can trunk 5, 10, 20, 30, whatever numbers you want across that, that's fine. This is considered a trunk, but in the idea of a VoIP phone, it's kind of special. And in Cisco, there's a special command to say this is a voice VLAN, and it's going to be traveling along with the data VLAN on this port. but it's not really configured as a trunk, and we'll show that. But it is a trunk by nature, essentially. So we also have a management VLAN. We configured that before, used for maintenance and stuff for your devices. Any sort of remote access, SSH and stuff, that's going to go over your management. On a layer 2 switch, or device of any kind, you're going to be able to assign one IP to that device, and that's going to be your management IP. If you have a layer 3 switch, which has the ability to, speak layer 3, you can create an SVI. Remember that the virtual interface? You can create an SVI, the interface VLAN command, for any VLAN you want, as many as you want. Layer 2 switch is limited in that there's only one management IP that you can use. The layer 3s you can have as many as you want, essentially. So that's one main difference, because the layer 2 really isn't meant to speak IP. It's supposed to be very basic. It talks layer 2 switching. It doesn't know anything about layer 3 really. The layer 3 is only used for remoting in and managing the device. So if you need to access a layer 3 switch access a switch from multiple locations, it might make the most sense to use a layer 3. Or remember I was talking about loopbacks? You could make a loopback potentially and then assign an IP to the loopback and then use that as your management, and then that would work from any direction or something. You can kind of fiddle around with things, but that's the main difference. Is layer 2 is one IP for management, layer 3 could be multiples. I mentioned the default native. We have a native VLAN. This is untagged traffic. So kind of like the example up here, if we have a switch and we have another switch and we have a bunch of computers hooked off of this thing and a bunch of computers hooked off of this one, this might be VLAN 5, 10, and 15, and then this is 5, 10, and 15. Maybe there are different closets in the same building or something, and then this is HR, and this is IT, and then this is corporate guys. But we need to communicate from over here to over here. We're going to do that with a trunk, so I mentioned that. So this is going to be a trunk. These are going to be the access ports. Remember that from the other work that we did with the port security? So those have to be access ports. So for the trunk port, any data that gets into this switch that does not come on some sort of VLAN tagged interface, like for usually it's for older communications, legacy type things, it's going to be assigned the native VLAN. So on each side, on each switch, switch 1 and switch 2, for this trunk, this one specific trunk, the native VLAN configuration has to match. So we could say native VLAN is going to be VLAN 99, and then over here we'd have to do the same thing, native VLAN 99. So then any untagged traffic that makes its way into these switches gets put onto this trunk on VLAN 99, because when it goes across the trunk it has to have some sort of VLAN associated to it. So just know that you have to match it on both sides. But then if I had a connection coming off here to another switch, and he has another trunk, I could technically, usually it's standardized, but I could technically have native VLAN 70 or something, and then on this port I could say native VLAN 70. So it doesn't have to be across the board. You could do it per trunk. But the native is untagged traffic that's made its way onto the switch. So older type of traffic, what do I do with it? It's got to go somewhere. So that's what it goes onto. If you have a mismatch of your native VLAN, your trunk will not work. It won't come up correctly. So as you go through troubleshooting and you're trying to do this on your own, that's something that will come up that might be an issue, make sure you set your native VLAN correctly. And we'll go through that. In order to see your VLANs, you saw me do that already, and we'll do it again coming up. Show VLAN when you're on a regular switch. If you're on one of those routers with a switch card, you have to go into like VLAN database and then say show. It's a little bit different. You can also do show VLAN brief, kind of like our friend IP brief, or show IP int brief, which will obviously show a more condensed version of the VLAN output. So I've talked about these trunks here. So for trunks, they use a standard, which is called, there's been different kinds coming out many years ago, but what we use now is IEEE. Sound familiar? So IEEE 802.1q. And that's our normal method of trunking. There's been others in the past. But what we use is IEEE 802.1q. When we go in to the trunk configuration in the next video, I think it's either the next video or the one after, we'll go and do some trunk work. And when you set a trunk, you have to go in and say, what encapsulation am I using? And it will actually say encapsulation.1q. It's actually DOT1q. So we're actually going to tell it, use this. We want to use the standard. So that's commonly used. It's pervasive. And so trunks allow multiple VLANs. Across a link. And you saw that with my little diagrams I drew in the last page there. So when we have switches that are all over the place, and they have connections between each other in some sort of high availability environment, got a whole mesh thing going on here, all these are going to be trunks. All these links are going to be trunks. And then all the ones coming off for our access ports, they're going to be regular access ports. These are going to go out to the host devices, the servers, the PCs, things like that. Hopefully that makes sense. And then they don't have to be all one color. Probably shouldn't have done that. So like this could be, you know, VLAN 10, this could be VLAN 5, this could be a straggler of VLAN 5, this could be VLAN 15 or something like that. They could be all different types, and then these trunks will carry that network traffic of these different networks between the switches as necessary. So if I'm trying to go, let's say I have a purple guy down here too, if I'm trying to go from here and I want to go talk to this one over here, I need to traverse this link. So this link needs to carry this traffic. It needs to allow my VLAN 15 or whatever it is, so that my packets can make its way down into this switch, and then it will go out to the correct port. Otherwise, if this link does not allow my VLAN, I can't get there. So that's one way of breaking up our network. So let's go talk a little bit more about this. So you have to set, well, you don't have to set the access. There's also that dynamic method. Remember in the other video it yelled at me about using the dynamic port. We had to set it to access. So the other option you have is access ports. And access ports are only for host/end devices. The idea being access ports are anything but a switch, essentially. So if it doesn't need to carry more than one VLAN, then it's going to be an access port. If it's one VLAN, it's an access port. If it's multiples, it's a trunk. The exception being that voice VLAN, which the port still ends up being an access port, but it kind of throws the voice in there too. And it really is a trunk, but it kind of gets treated specially. So, and again, the reason for these trunks is, like I have these 3 different colored VLANs, if we didn't have these trunks here, we'd have to waste ports to carry this traffic. So if I wanted the blue VLAN to get over here, I'd have to have a blue link. If I wanted the green to get over here, I'd have to have a green link. If I wanted the purple, I'd have to get the purple link. So it would be a huge waste of interfaces on our switches to do that. Especially if most of the traffic is idle and it's not being used, we'd be wasting not only links but bandwidth, and be a lot of money spent for no reason. So trunks really help us keep our port use efficient. So the 802.1q is an add-on. Remember I was talking about we've been stuffing things into the headers for IP and Ethernet and such. Over time we've realized, well, we'd really like this kind of functionality, but the header doesn't have that option in there, so let's make a new standard. That's what happened here. So with 802.1q we added 4 bytes into the header, and the 4 bytes have some specifics in there about quality of service, and it has what type it is, what identifier. It'll have a little bit that says this is token ring or not over Ethernet, which isn't really used. But it'll also have the VLAN ID, which is really the important part. And what VLAN number, which is 12 bits, which identifies the VLAN number. There are 4,096 VLANs supported. And the quality of service is something that we'll start talking about a little bit more, especially with this voice over here. We want to make sure that our voice traffic gets to where it needs to go and our voice isn't all chopped up. And we'll want to prioritize that over data usage. So, as I mentioned so many videos ago, if my web page loads 1 second slower, I'm probably not going to notice or care. But if my voice gets chopped up when I'm using voice over IP, well, that's going to be a major problem. So inside this 802.1q, we also have some quality of service values in there for priority of traffic. Also, when we add this 802.1q specification into the mix, we do create a new frame check sequence, the FCS. Remember the meat grinder we were talking about? It'll recalculate everything and make sure that it gets a correct value in there, since we are stuffing new stuff and new things into the header. So now we've gone over some of the things about the trunks and creating VLANs. Let's actually go ahead and do that. So our next video will go over how to actually make VLANs. You've seen me do a couple already, but we'll do it in a more verbose manner. And then we'll make some trunks, and we'll make some communication work between those.